On October 26, 2020, NASA confirmed that with their stratospheric observatory for infrared astronomy, or Sofia, they have found water on the sunlit surface of the moon. But this is not the first time NASA has confirmed the presence of water on moon. Then why this discovery by Sofia in 2020 is making scientists more excited? Though it is just 12 ounces of water they found, which can only be used for 2 cups of coffee, so traveling almost 384,000 kilometers or 239,000 miles for 2 cups of coffee, it's a little bit too much. So the question is, does moon have a lot of water than we expected? How scientists have found it so far? And why Sofia's discovery is important for future space explorations? If you are with me so far, press subscribe and keep getting notified whenever we ask this question. Is it possible? At first, scientists took the moon sample from Apollo 15 and Apollo 17 missions and they found tiny glass beads which was formed with volcanic activity 4.35 billion years ago, when the moon was volcanically active. In year 2007, scientists sliced those beads looking for water and they found a significant amount of water, with the concentration highest in the middle of the beads. That shows that water was trapped there during the volcanic eruption, otherwise it must have been more dry in the middle if water was leached in due to contamination after those beads were brought back to Earth. Since this water came from the interior of the moon, so the moon must have contained water at first place. And it makes sense considering that moon is more likely to be the part of Earth which was separated in an impact with a Mars-sized celestial body billions of years ago. Since this water wasn't enough to build a sustainable colony, scientists were looking for some bigger sources. They have hypothesized that there could be a lot of water inside the cold traps in the polar regions of the moon. So what are these cold traps? Cold traps are the deep craters in the polar regions of the moon. And because of their geological location, these craters haven't received sunlight for more than 1 billion years. So even if the water-bearing comets, asteroids and meteorites brought the water on moon, or it produced from the chemical reactions of hydrogen ions from the solar wind impacting oxygen-bearing minerals on the moon, this water could be trapped in there in form of ice. Because these permanently shadowed craters are some of the most coldest places in the whole solar system, that it can reach -249 degrees Celsius. And combined, these cold traps cover the area of 40,000 kilometers square, that almost as large as Switzerland. At first, scientists were looking for hydrogen because when there is hydrogen, there is possibility of water. Some lunar mission indicated the presence of hydrogen on the southern pole of the moon, but had not been sure whether it was in form of water H2O or its close relative hydroxyl OH. NASA used its Lunar Exploration Neutron Detector for detailed measurements, and from the data they took, highly suggested there could be frozen water within the soil of these craters. So in 2009, NASA's Lunar Crater Observation and Sensing Satellite mission deliberately impacted part of its launch vehicle into southern crater, Clavius. This strike ejected 10,000 tons of material, with half of it making high enough to be exposed by the sunlight. And with the Lunar Orbiter spacecraft, scientists detected that 5.6% of this material is water. So, if we already found big amount of water in these polar craters, why Sofia's 12 ounce seems more heavier? Well, as I mentioned earlier, they had found it on the sunlit surface of the moon in the Clavius crater, which is the second largest crater formation visible from Earth. During the daytime, temperature can go up to 123 degrees Celsius, and since Moon's gravity is weak and with almost no atmosphere, any water reached the surface with micrometeorites or maybe created in the chemical reaction is more likely to boil away into the outer space. This is why this discovery is raising some intriguing possibilities. This implies that water on the moon could be distributed throughout its surface instead of just being limited to the poles as previously thought. And getting water from the regions which are more sustainable is a lot easier and cheaper than getting it from the cold, dark and deep craters. And also, if water could exist in such unusual environments, so maybe we could find it on another planet we haven't expected. Geologically, it is an amazing discovery that will greatly impact the future of exploration. So the presence of water on the moon also indicates the presence of alien life on the moon? We will consider this possibility in another Is It Possible?